Hello everyone, welcome back to the channel. In the last video, someone reported there was a noise voice issue in the videos. Actually, there was a problem with my iPad. I have to get it repaired, the microphone, and I've just got the iPad back. So sorry for the delay. I will try to compensate for the time lost and try to complete the syllabus as soon as possible. So we are going to continue to follow the same pattern as we have done in the last videos. So we were doing arithmetic, and there were three topics left in arithmetic, but I'm now moving to number system first. Why? Because since I have also seen there was a voice issue in the last videos, I will have to see if I have to re-upload those videos with the correct voice, or anyways I will be uploading those three remaining videos soon for the arithmetic topic. So today we're starting with the topic number system. As I've already told you, arithmetic, number system, and algebra. These are the three topics which you cannot afford to not be prepared with. Only these two topics are very important, and if you have done these three topics from quant, plus if you are able to do 10 to 12 questions in verbal, you are good to pass the threshold 33% in the CSAT exam. So let's start with number system and let's see what are the topics. In number system, today we are going to do the basics of number system. Basics include what number is, what even number is, what integer is, and so on. Then we are going to do the remainder, decimal, divisibility rules. Divisibility rules, I would say, very important. Every year you can expect at least 3 to 4 questions from this area. They are quite simple if you understand and if you remember the divisibility rules, and you will be able to do that. Prime number is another topic, I would say, important, because you have to understand what a prime number is, and the questions are, I would say, on the trickier side, but after you understand the concept of prime number, you should be able to do that. HCF LCM, low priority topic in this specific number system, but still we are going to cover that HCF LCM. So let's start with the first topic, that is the basics of number system. So if you see, we have total of 5 questions in 2020 and 2019 exam, 3 plus 2. So these are those 5 questions. We have 3 questions in 2020 and 2 questions in 2019. We are going to do this after we have done with the theory of number system. Let's start with the theory of number system. Okay, starting with the basics of number system. What is a number, or what is a number, right? Or what a number line is. So I'm pretty sure you have seen this number line somewhere in your class 10th, 8th, 9th. We make a line. This line goes on one side to plus infinity. On the negative side means it goes till negative infinity, and there is a number 0 in between. I hope this is clear. So this is how a normal number line looks like. And if you see here, if you 1 is written here, 2 is written here, 3, and number goes on increasing till they goes till infinity, right? And if we come on the left side, -1, -2, -3, and so on, right? I hope this is clear. So if you see, if I go from left to right, the numbers are increasing. How number are increasing? If someone asks you, is -3 greater or 3 greater? Means which one is greater, -3 or 3? Because -3 is on the left side, the +3 is on the right side, so +3 is greater than -3. I hope it is clear, right? So this is how you represent numbers on a number line, right? So these are numbers, and I'm pretty sure if you just zoom in this, if I zoom this 0 to 1 part, I'm just zooming this number line here. Zooming means I'm just showing you what the elements between 0 and 1 looks like. So it is 0 is here, 1 is here, right? So I'm sure you will have 0 0.1, 0 0.2, 0 0.3, so on till 0 0.9 between 0 and 1. If you zoom in more, you can also see 0 0.01, 0 0.02. If you zoom in more, you can also find 0 0.01, 0 0.0001 and so on. Means there are infinite numbers between 0 and 1, right? And I hope you are getting a picture what a number line looks like, right? Now you have to know these terms by heart. By heart means what these terms represent, means what is a natural number, what is an integer, what is a rational number, real number. Why? So in the exam, if I'm going back and I will show you the previous year question. Just observe these things. If I go here, you will see they have said these are natural numbers. If you go here, they say these are odd numbers. If you go here, this is another question. If you go here, these are natural numbers. If you see here, this is another basics. So means you have to know what a natural number is, what an integer is, and you do not get confused in the exam, right? That is very important. Now here, I am going to do one thing. I am going to start with defining these terms, and we are going to move to the more difficult question part as we progresses, right? Let's start. Now starting with, what is a natural number? See, natural number is, I will simply tell you, if you start counting from 1, 2, 3, 4, 5 and so on till 100, so on till 1000 and so on, means you have to start the counting from 1, right? If you start the counting from 1 and take all the non-decimal numbers, that is a series of natural number, right? If someone asks you what is a series of natural number, you will say 1, 2, 3, 4, 5, right? If someone asks you, is -3 a natural number? No. Why? Because the natural number series start from 1, right? If someone asks you, is 1.5 a natural number? No. Because natural number are only non-decimals. I hope it is clear. Now whole number is nothing, just a 0 is added to the natural number series, means 0, 1, 2, 3, 4, 5 and so on. So only the difference between natural number and the whole number series is there's an extra 0. So whole number series starts from 0, right? Now what is an integer? See, integer, if someone give you a number 1, 2, 4 and they ask you, is it an integer? So just understand what is an integer. See, simply this is, I'm sure you must be familiar with the decimal. 124.5 is a decimal. Why? Because it has a non-zero after decimal, non-zero digit after decimal. Even 124 can also be written with a decimal. 124 is equal to 124.0000 and so on. But does 124.000 contains any non-zero number after decimal? No. So integer are simply saying integer are non-decimal numbers. Is this an integer? Is that 124.5 an integer? No. But is 124.0000 is an integer, or simply is 124 an integer? I would say yes, because there is no non-zero digit after decimal, right? I hope integer is clear. I hope decimal is clear. Natural number and whole number are these are done. Now, if you have seen the last previous year question I've just shown you, there was a term known as odd integers or even integers, right? Now you understand what is an integer, non-decimal. So now let's say 1, 2, 3, 4, 5, 6, 7, 8, 9 and so on. And one more thing, difference between an integer and a natural number is integer also has negative numbers. Means if I write a 0 here, then I minus 1, minus 2, minus 3, minus 4. All these are integers. Why? Because these are non-decimals. There is no restriction on that it has to be greater than 0, it has to be greater than 1. No restriction on integers. Integers are simply non-decimal numbers on the number line. So on the number line you also have negative parts. So these all are negative integers, but negative numbers are not natural number and negative numbers are not whole numbers, but all the negative numbers, all the negative non-decimal numbers are integers. I hope this part is clear. Now let's see. What is an even integer? Even integer is simply which is divisible by 2, and odd number digit which is not divisible by 2. This is very easy. You know what divisibility by 2 means? Means the table of 2. 2, 4, 6, 8, 10, 12, 14, 16 and so on. These all are even integers. And if I say 1, 3, 5, 7, 9, which are not divisible by 2, are odd numbers, right? And if I go back, 0, minus 2, minus 4, minus 6, minus 8. So all these are even integers, and minus 1, minus 3, minus 5, all these are odd integers. I hope this is clear. So just to give you an idea, if someone give you very big number, 1, 2, 4, 6, 8, 9. If someone says you, is this an even integer or odd integer? First thing, is it an integer? Yes, because it's a non-decimal. You just check the last digit of the number, that is 9. If the last digits is 1 of 2, 0, 2, 4, 6, 8. If the last digit is 1 of, it is either 0 or 2 or 4 or 6 or 8. It will be an even number. Otherwise, if it is 1, 3, 5, 7, 9, it is an odd integer. So it is 9. So we will say this whole number is this complete number 1, 2, 4, 6, 8, 9 is an odd integer. I hope it is clear. Odd integer and even integer. Let's move to the next topic. That is rational numbers. Till now integer is clear. Integer is non-decimal numbers, right? So what is rational number? Rational number, to define rational number, take two integers p and q. I am taking two integers which are p and q. Now tell me, if p is integer, give me an example. I would say 100 is an p means p is 100 and 100 is an integer. Give me an example of q which is an integer. I would say take 132. Is this an integer? Yes. Why? Non-decimal. Now divide first integer by the second integer and this becomes our rational number. Divide first integer by second integer, then it becomes a rational number, given the only condition in other it has to fulfill is q cannot be equal to 0. Q cannot be equal to 0. If q becomes equal to 0, then it is then it becomes a non-rational number, right? So I will give you two examples. Tell me if this is a rational number or non-rational number. We are just going by the definition for now. This is 124, and the other example is 100.468 divided by 3, 2 something. I'm just taking as a random example. Third example is 42 divided by 0. Now tell me, is first 100 divided by 124? I will just write it again to clear the confusion. This is 100 divided by 124, say. First is a rational number, yes, because one integer is divided by second integer, so this is a rational number. Second condition, which condition it does not fulfill? Because the numerator means one non-integer is getting divided by an integer, so this is not a rational number. Third thing, there are two integers, 42 is an integer, 0 is an integer, but always remember, it cannot get divided by 0. So it is not a rational number. If someone gives you, is 0 a rational number? Means 0 by 1. Obviously any number you can write it as, suppose number 4. You say 4 is equal to 4 divided by 1, right? So 0 is a rational number. 0 divided by 1. This is a number. They are asking you if 0 is a rational number. Yes. Why? Because 0 is an integer, 1 is an integer, and q, which is 1, is not equal to 0. So that is why 0 is also a rational number. But 42 by 0 is not a rational number. I hope this is clear. Rational number, non-rational number, irrational number, right? Now, this is a classification of number. I will tell you what a real number is. Real number, till now, have you understood rational number? Right? Rational numbers. Take all the rational numbers in the world. Take all the irrational number in the world. Make a complete series. Means I will pick, suppose 50 rational number, and another I am picking, suppose a 50 irrational number. Take them together, and this whole family is a family of real number. So what is a real number? This is a complete set of all the rational number and irrational number in the world, right? So real number is get divided into a rational number and irrational number, right? Now, rational number can be further divided into, we know by the definition it is a p by q form, where p and q are integers and q is not equal to 0. This is just we have done in the last video. If you see the decimal form, we have a terminating decimal form. Means suppose I start writing 6.245 and there is nothing after 5, right? There is nothing means there is no non-zero after 5. Is this a decimal? Yes. Is this terminating? Terminating means, is it stopping somewhere? Yes, because after 5 there is nothing. So that is why it's stopping somewhere. So 6.245 is a rational number and that is terminating decimal. Now tell me what is non-terminating repeating decimal form. Just let's break this up. It is of some form, decimal form. Yes, 245. Now it is non-terminating repeating, means some part is getting repeated. Means suppose 45, 45, 45, 45, 45. Is some part repeating? Yes. So this is non-terminating, means this is not ending anywhere, but still some part is getting repeated. So that is where this is another way to find if it is a rational number. The rational number first is by definition, this means p by q form, one way. Second way, it has to be a terminating decimal, second way. Third way is it can be non-terminating, means it can go on forever, but there should be some repeating pattern in the decimal part, right? Now let's see. If you see irrational, it says it can also be p by q form. Why? We have just understood p by q form is always a rational number. No, here what the difference is, either p is not integer, q is not integer, something means some definition is not getting satisfied. Means suppose I am taking example of 100.8 divided by 42. This is also p by q form, but the only thing is p is not an integer. So that is why irrational number can also be represented in p by q form, but they will not follow the condition. P and q has to be integers. I hope this part is clear. Now, last thing is non-terminating, non-repeating decimal form. Means first thing, decimal, it is a sum of decimal form. Yes, 2, 4, 5. It is non-terminating, means it will go on forever. And the second part is non-repeating, means 2, 4, 5, 6, 7, 7, 3, 7, 3, 4, 2, 8, 6, 7, 9, 8, 4 and so on. Means there is no specific pattern. Nothing is getting repeated. Like in the other case 45 was getting repeated, but in this case nothing is getting repeated. This is all random. So these are all irrational number. Irrational number is non-terminating, non-repeating. Now for the next part, You just have to focus on this thing, only this thing. This is where the question can come from, this part. You have to understand the irrational number is non-terminating and non-repeating, and or otherwise it does not follow that some of the conditions of p by q. In rational number, now I will show you how the question can come from this rational number part.